We're going to go over in this video function operations. So when you have function operations, it's just the operations that you can perform on any type of function. So the four operations are adding. Now this is the notation you're going to see where your new function is made by adding two functions together. So this says f plus g of x. So notice its name is f plus g because it's a new function that was created by adding f and g together. This does not say take f plus g and multiply it by x. Remember, this is function notation, okay? This is the name that you give the function. So the name of the function is f plus g. Another way that also means, that you are going to be adding two functions together, or you could just see f of x plus g of x, okay? Subtracting, if you see this means your new function's name is f minus g of x. It came from taking f and subtracting g. So you could see it like this, or you could see it like this, but they both mean you're subtracting, okay? You're taking g from f when it says f of x minus g of x, or f minus g of x. Multiplying, okay, f times g of x, its name is f times g. That's because it was made by multiplying the function f by function g, or you could just see it as f of x times g of x. These two expressions mean the same thing. And lastly, dividing, okay, f over g of x is the same as f divided by g of x. That's the same as saying that you're taking function f, dividing it by g of x, and that is your new function. So we're going to take a couple functions, we're going to go over domain, and we're going to do operations. So please copy down these 6 functions. We're going to be working with these 6 functions in this video about operations with functions. And the first thing that we're going to do before we do any operations, let's just review domain of functions. So let's look at f of x. F of x, we see right here, is a polynomial of degree 2, okay, quadratic. Right now, our domain restrictions will come from, remember we talked about this already, you can't have a denominator of 0, okay? You can have any number but 0, you can have any number in the numerator, but you can't have 0 in the denominator, and the square root of a negative number, but really any root that's even of a negative number, okay? Those are going to be your not real solution, not solutions, but not real outputs. So you can't plug any real number in if it's going to output one of these two things. So let's see, is there any real number that I can plug in and somehow end up with an output that's like this or this? No. So f of x, any quadratic, right? Domain, all real numbers. G of x is another quadratic, all real numbers. M of x is a linear function, okay? There's no real number that I can plug in that'll output something that's not real. These are not reals, so all real numbers, okay? N of x, 1 over x minus 2. So look, this is the first time I've got a variable in the denominator. So can you think of a number that I could plug in that I could get a number over 0 or square root of a negative? Yeah, there's one number I can think of that can make the denominator 0 here, okay? So to figure it out, what makes the denominator 0, and we have to make sure we restrict it. So we can't have 2, all reals except 2, okay? If you wanted to write these in set notation, this is negative infinity to infinity, negative infinity to infinity. We talked about already about how we don't use closed brackets when we talk about infinity, negative infinity, because we can never really reach that. To say all real except 2, that means you have to include everything but 2. So if you use set notation, negative infinity, comma 2, parenthesis, is in union with parenthesis 2, comma infinity. So the parenthesis, because you can't be 2, okay? And then when you have 2 different intervals, you just put them together with this union notation, okay? P of x is a square root, okay? We cannot have a negative under the square root, so we have to make sure that the expression, if it's saying it can't be negative, means it can only be non-negative. So that interval will be x plus 1 is greater than or equal to 0. So that's going to be when x is greater than or equal to 1. If you want to write in set notation, okay, close bracket, negative 1, comma, infinity parenthesis. Now the reason this isn't an interval and it's just everything but 2 is because there's only one number that we have to be concerned with. We have to just make sure that the denominator isn't 0. Here we have to make sure that we figure out all of the values that will produce not a negative number, okay? So you can only have non-negative values. Q of x is a cubed root. You can have a positive radicand, you could have 0, you could have a negative radicand. So that's all real. Okay, so just a little review of stating domains. And so now we're going to perform operations with these functions. So the first two problems that we'll do, okay, this right here says that we are going to have a new function by adding f with g. Now notice it says state the domain of the result, okay? So what this is saying is our new function is made up by taking f of x and adding it with g of x, okay? Now technically, okay, we're doing this. So we're taking f of x, which is x squared plus 2x minus 1, okay? And we're adding it with g of x, which is x squared plus 3, okay? Do we need the parentheses here? Not really. X squared plus 2x minus 1 plus x squared plus 3. And so what we want to do is we want to check, okay, domain of the result. We want to check the original, okay? Did we have any domain restrictions for f of x? No, it was all real. Did we have any for g of x? No, it was all real. And now let's see, x squared plus x squared, that's going to give us 2x squared. Make sure we simplify our expression as much as possible. I've got a plus 2x and a negative 1 plus 3. That's going to put me at plus 2x plus 2. And now, do I have any new domain restrictions that I've come up with? No. So my domain of my result is just all real numbers. Okay, number 2, it says our new function's name is m plus n of x. So we have to add together m of x with n of x. So m of x is 2x minus 3 plus n of x is 1 over x minus 2. There's nothing to distribute here, so we could just 2x minus 3 plus 1 over x minus 2. Okay? None of these terms are like, okay? These three, you can think of this, okay? You have 2x, you have negative 3, and then you have the term 1 over x minus 2. You can think of it as a term here. So you can't combine this with either of these, so you just leave it as is. Okay, now think of this. M of x, did it have any restrictions? No. Okay, n of x, did it have any restrictions? Yes. X couldn't be 2. Notice, whatever these two restrictions, if there are any restrictions here, you're going to pick up with it when you're adding. Okay, notice, all reals here, but x can't be 2 here. Notice what we have going on here. Our domain for our newly made function right here would be all reals except x can't be 2. Okay, so that's 2 adding. In number 3, we have our new function is going to be f minus m of x. So that is by taking f of x, okay, and subtracting m of x. So we are subtracting the entire function. So this is going to be x squared plus 2x minus 1 minus 2x minus 3. So that's why it's important with these parentheses here. You are subtracting m of x. M of x has 2 terms. So this is x squared plus 2x minus 1 minus 2x plus 3. Okay, it's going to be x squared. These cancel. We're going to be left with x squared plus 2. So, okay, no domain restrictions, no domain restrictions. So if we look at this, what do we see? No domain restrictions. Okay, number 4, g minus p of x. So this is made up by taking g of x and subtracting p of x. So this is going to be x squared plus 3 minus the square root of x plus 1. Okay, this is just one term right here. There's nothing to, okay, there's not multiple terms here, so we're just distributing to this term, so it's going to sit in front. There's nothing to combine here. I can't combine this 1 and this 3. This doesn't really have a value of 1 here, right? It's doing x plus 1 and then taking the square root. So no domain restrictions. We had a domain restriction, and we see it again right here. Okay? The domain of this is x has to be greater than or equal to -1. Okay, so now let's do some multiplying. Okay, so in number 5, our function is going to be, our new function is going to be g times m of x. So we have to take g, function g, x squared plus 3, and multiply it by m, 2x minus 3. So we have 2 terms by 2 terms, so we just multiply it out. This is a polynomial times a polynomial, so technically this is just multiplication of 2 polynomials. So this will be 2x to the third minus 3x squared plus, okay, 2x to the third, sorry. That's going to be minus 3x squared plus 6x minus 9. Okay, there's no terms to combine here. G, did G have any domain restrictions? No. Did M have any domain restrictions? No. Look at your new function. It's just a third degree polynomial. Does this have any domain restrictions? No. So the domain here, all real numbers. Number 6. F times n of x. So we're taking f, which is x squared, plus 2x minus 1. And we're going to multiply it by n, which is 1 over x minus 2. So we've got a fraction going on here. Remember how to multiply fractions together. I could take this expression and make it a fraction, okay? I can make it a rational expression here. I could just write it all over 1. So remember, you know how to multiply fractions together, right? Numerators get multiplied together. That's going to give us x squared plus 2x minus 1 over denominators get multiplied together, x minus 2. So it's just this sitting over that. So does f have any domain restrictions? No. Does n? Yes. X can't be 2. And notice, the only domain restriction we have here is what's carried over from n, in which the domain is all real except 2. Okay, and last, g times q of x. So we're going to take g's x squared plus 3, and we're going to multiply it by q, which is the cubed root of x minus 5. Now, there's only one term here, so there's really nothing for us to do here. We can just leave it as x squared plus 3 times the cubed root of x minus 5. What else could you do? I guess you could technically write this, x squared times the cubed root of x minus 5 plus 3 times the cubed root of x minus 5 if you really want to. But you can leave your answer just like this or this. And, okay, did G have any domain restrictions? No. Did Q have any domain restrictions? No. Look at your product. You're not going to get any domain restrictions from it. Nothing new is popping up that would create that. Okay, so that's multiplying. So now let's do some dividing. Okay, so in number 8, our new function is going to be made by taking f and dividing it by m. So we have to take function f, which is x squared plus 2x minus 1. And we have to divide it by 2x minus 3. Notice we don't really need our parentheses here, okay? We have x squared plus 2x minus 1 over 2x minus 3. Now, when we're just doing function operation, okay, I don't want you to actually do division of polynomials here. Okay, I'm going to be just concerned with the domain restrictions that have to do with these, okay? I'm concerned with just the domain restrictions. So notice, f didn't create any domain restrictions. M didn't create any domain restrictions. But because I'm dealing with division here, have I created any new domain restrictions? Yes, because now I have what's called a rational function here, okay? I have variables sitting in my denominator. If you have variables sitting in your denominator, you should be concerned with making sure that you do not plug any number in that could make the denominator 0. So whenever you're left with an expression with variables in the denominator, we have to figure out what values make this 0. And then we have to exclude that from our domain. So if we add 3 to both sides, we get 2x equals 3. Divide by 2, we get x equals 3 halves. So all real except 3 halves. Okay, now we can see that in this problem we just did that it's just going to be one value that needs to be excluded because there's only one thing that could make this 0, and that's the only kind of restriction that we have. So let's take a look at 9. 9 says we're going to take g and put it over p. So that's going to be x squared plus 3 over the square root of x plus 1. So that's just going to be x squared plus 3, we don't really need those parentheses there, over the square root of x plus 1. Okay, so g did not have any did not have any domain restrictions to begin with. P alone did. P had x is greater than or equal to -1. Now, look at your newly created function. Not only do you still have that square root, but now the square root is sitting in the denominator. So this domain restriction right here makes sure that this is never the square root of a negative number. But the issue here is I can't let the denominator be 0. So what is going to make the square root of x plus 1 equal 0? Well, if we square both sides, we get x plus 1 equals 0, x equals -1. So not only, okay, do we have to make sure for this expression right here, okay, not only do we have to make sure that the radical, okay, the square root, doesn't end up with a negative radicand, but because this expression is sitting in the denominator of a fraction, we need to make sure that this never evaluates to be 0 either. So if I combine x has to be greater than or equal to -1, and x now can't be -1, that means my domain here is going to be x has to be greater than -1. Because anything, if it was -1, okay, you'd get -1 plus 1, which is 0, the square root of 0. But you can't have x squared plus 3 over 0. That's a problem. Okay? Number 10, n over f. N divided by f. So that's going to be 1 over x minus 2 all over f, which is x squared plus 2x minus 1. So this is called a complex fraction. Okay? We've talked about this before with numbers. I've got a fraction within a fraction. So I technically have two fractions here, okay? I have this fraction, that's the numerator of the larger fraction. So I technically have two denominators here. I have this denominator, and I have this denominator. So I have to make sure, when I do domain restrictions, I need to make sure both of these never end up being 0. So if you want to grab them now before we simplify this, you might want to do that. So what's going to make x minus 2 equal 0? Well, that's going to be 2. Now, what makes x squared plus 2x minus 1 equal 0? Okay, well, I can't factor that, so I got to use the quadratic formula. Okay. So now we have to use the quadratic formula to find the values that are going to be domain restrictions. So that's going to be -2 plus or minus the square root of 4 plus 4, that's going to be the square root of 8, all over 2. Okay, if you left it like this, we didn't simplify our radicals yet, so if you left it like this, that's fine. But the square root of 8 can simplify to be 2 square root 2, which this would simplify down to be -1 plus or minus the square root of 2. Okay? So now let's get back to simplifying this expression. Here are our three values that are going to be domain restrictions, okay? So if we need to simplify this expression, okay, you know how to simplify complex fractions, okay? Dividing by this is the same as taking 1 over x minus 2 and multiplying it by 1 over x squared plus 2x minus 1. Okay, so now I'll just put this right up here. That's going to give us 1 over, and now we have a binomial times a trinomial. But if you look, these are the three values, okay, that would make the denominator 0. We already found them. So when I multiply this out, this is going to give me x to the third plus 2x squared, okay, minus 1x minus 2x squared minus 4x plus 2. That's going to give me x to the third, the x squareds cancel, minus 5x plus 2. You see how, okay, this is a third degree polynomial. I need to find all of the values that make this 0. You already did that, okay? So the domain is all real except 2 and then -1 plus. the square root of 2, and then negative 1 minus the square root of 2. Okay, so that one was a little tricky. You have to make sure, if you have a fraction within a fraction, okay, you have to make sure all of the denominators can't be 0. Okay, so that's it for operations with functions. Just make sure, adding, subtracting, multiplying, dividing, that you are not only getting the result, okay, making your new function, but you're also stating the domain of the function that you just created.